Hello everyone. Today I'm returning with a new video to demystify yet another topic in mathematics. I'm sure you have learned about the divisibility rule of 3 in your school. It involves adding up the digits of a number to determine if it is divisible by 3. For example, if we want to find out if 462 is divisible by 3, we add the digits 4, 6 and 2, which totals 12. Since 12 is divisible by 3, we know that 462 is also divisible by 3. On the other hand, if we consider the number 356, the sum of the digits 3, 5 and 6 is 14, which is not divisible by 3. Therefore, 356 is also not divisible by 3. Have you ever questioned why the seemingly random number 14 was significant in determining the divisibility of 356? You may know how to apply the rule, but do you really understand why it works? While it can be entertaining to simply watch a magic trick as an audience member, it is more thrilling to learn about how the trick was performed and see the mechanics behind the magic. So let's find out. To truly understand the mystery behind this divisibility test, it is important to realize that the correct question to ask is, what is the remainder when a number is divided by 3? For example, if I have a pack of 10 candies and I try to distribute them evenly among 3 children, I will have one piece of candy at the end that cannot be distributed without being unfair. This remaining piece is called a remainder. Now imagine that you have a box of 100 candies that you want to distribute evenly among 3 children. One way to think about this is that 100 candies are made up of 10 packs, where each pack contains 10 candies. When you distribute each pack among 3 children, you will have 1 candy left over from each pack. This means that you will have a total of 10 remaining candies in the box. However, you can further distribute these remaining candies among 3 children, which will result in a remainder of 1 piece of candy at the end. These two facts will be helpful as we try to understand more complex examples, so keep them in mind. 1. That when a pack of 10 candies is distributed among 3 children, the remainder is 1 candy. And the second, when a box of 100 candies is distributed among 3 children, the remainder is also 1 candy. Now let's consider a more complex example. Imagine that you have 356 candies, which consist of 3 boxes of 100 candies, 5 packs of 10 candies and 6 individual candies. We know that when one box of 100 candies is distributed, the remainder is 1 candy. So 3 such boxes will have a total remainder of 3 candies, 1 candy from each box. Similarly, we know that when one pack of 10 candies is distributed, the remainder is 1 candy, so 5 such packs will give us a total remainder of 5 candies. When we combine these remainders with the 6 individual candies, we have a total of 14 candies. Did you notice something interesting here? Despite not using any special techniques or tricks, we ended up with the same number 14 after the initial distribution. This number 14 was also the sum of the digits of 356 that we saw earlier. If we continue and try to distribute these 14 candies among 3 children, we will find that we have a remainder of 2 candies. This means that when 356 candies are evenly distributed among 3 children, the remainder is 2, and therefore 356 is not fully divisible by 3. Imagine another example where we want to distribute 462 candies among 3 children. 462 candies consist of 4 boxes of 100 candies, 6 packs of 10 candies and 2 individual candies. 4 boxes when distributed give a remainder of 4 candies. 6 packs when distributed give a remainder of 6 candies. So the total remainder is 4 plus 6 plus 2, that is 12 candies. It is also worth noting that 12 is the same number that we get after adding the digits of the original number 462. We can distribute these 12 candies further and we will be left with no candies as a remainder. This means that when 462 is divided by 3, the remainder is 0 and therefore 462 is fully divisible by 3. I hope that by now you have realized why adding the digits of a number is useful for the divisibility test. This divisibility rule is not just limited to 3-digit numbers, but can be applied to numbers with any number of digits. Can you try to reason out why this might be the case? Feel free to share your answers in the comments below and let me know if you enjoyed this video. Also, please let me know what subject you would like me to cover next time in this series of videos. Don't forget to like the video and subscribe to the channel. Thank you and goodbye.